Hey guys, welcome. This is for our recording of 2.1a, lesson 1 of 2, where we're going to be looking at circumference for today, circumference of a circle. All right, so here on slide 2, this is going to be our warm-up. I'd like you to try this on your own, and then I'll go over the answer in a moment, but I'll read through what's going on first. So first question is AB is a what? So AB, is that a radius, diameter, or chord? AB. And then next, same three options, AC, A to C, which one is that? And lastly, AD, which one is that? Radius, diameter, or chord? All right, so I encourage you to pause this video, try this on your own, and then come back when you're ready to check your work. All right, so assuming that you have paused the video, we've got our answer. Let's see. So A to B, so we can tell that B is in the dead center of this circle. And A is on, that point A is on the outside of this circle. So because it's going from the dead center to like any point on the outside of the circle, AB is going to be a radius. That's a radius. So radius is again going from the center of our circle out to any other point on the circle. AC, we can see going from A to C, it's going through B, through the center to the other side of the circle. And it looks like it's a straight line. So another way we can think about this is it's almost like it's cutting this circle in half, right? You can kind of visualize that. We've got a piece over here and a piece over here. So because it's going through the center of the circle, that's an example of a diameter. And then our last example, AD, so from point A to point D, we can notice, it's not going through the center. Interesting. This is point A is on the outside, just on the outside of the circle. Point D is also on the outside. It's not cutting through the center at all. So when it's not cutting through the center like this, we call that a chord, So here's just some recap, some vocabulary terms about parts of a circle. All right, and then we're going to click next. We're on slide 3. This is a part 2 warm-up. If BF is 14 inches, what is AC? If BF is 14 inches, what is AC? Again, I encourage you to pause the video, try this on your own, and then come back when you're ready to check your answer. All right, assuming you've got an answer, we're going to go ahead and check. So they're telling us that BF is 14 inches. Cool. What does that mean for us? BF, so, right, what is this? So this is from the center of the circle to a point outside of the circle, on the outside, the like outer rim of the circle. So that means that we're given, so BF is the radius. That's the radius. It's going to be 14 inches. And they're asking us, what is AC? And AC is going on either side of the circle, cutting through the center. So AC is, remember, AC is the diameter of a circle. And if you can remember, diameter is 2 times the radius. So we do have a calculator if you need some help here. We can check. 14 times 2, 28. So AC equals, so we'll say 28 inches, and then we'll just submit, so it saves our response. All right, so that's on slide 3. It's okay if you don't type all of this, you can just put 28 inches, that's fine. All right, 28 for slide 3, 28 inches. All right, we're ready to move on. If you need more time, right, pause the video because this is a recording. We're gonna jump to slide 4. We're gonna learn about this guy, Archimedes. He was a Greek mathematician, a physician, engineer, and astronomer. He discovered that in any circle, the ratio of the circumference to the diameter is always the same. And he called this ratio pi, or, and then we need to fill in the blank here, the symbol for pi. Here it is, pi. It's just like two parallel lines and then a little like inflection on top. That's the symbol for pi, and it is a Greek letter. It's from the Greek alphabet. So he found this ratio where pi is that it's always consistent. If for any circle, if we take the circumference divided by the diameter, we're going to get this same number, 3.1415, right? Blah, 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 blah. So I think that's pretty cool. Like, just like as an observation, just be like, oh, that's an interesting pattern to see. I don't think I could ever, I don't know if I could ever do something like that. Like just observe like, oh yeah, every circle, same ratio. So pretty cool that he did, helpful for us in math. So whenever we're hearing pi, 3.14159, right? I think we can actually, do they have it in the calculator? Yeah, they do. Pi, right? And here it is, 3.141592654. Some people like, I don't know if you've seen videos, some people like memorize up to like hundreds of letters or hundreds of like decimal places back. I don't know why you would want to do that, but if you do, good on you, because that's pretty impressive. And I can only go to the 9. That's all I remember. But anyway, we don't have to memorize it for our class, so don't stress about it. Just know Archimedes is the one that discovered this, and he called it pi. That's where it comes from, pi. All right, so this is going to be, because of the recording, we'll add this to our Engagely notes at a later point in time, because the recording. But circumference of a circle, so the circumference C of a circle is C equals, there's that magic symbol pi times the diameter. So that's how we get this, that distance for circumference. So D is the diameter of the circle and R is the radius. So again, diameter is going through the center, ending up on either side. Diameter also is like splitting our triangle exactly in half. So pretty cool. The radius, diameter is also 2 radiuses, right? 2 times the radius. That's why down here, circumference is equal to pi times the diameter, or 2 times r, right? Because 1 radius, 2 radius, that gives you the diameter. So either way, doesn't really matter. It's saying the same thing. Sometimes in problems, they'll give us the diameter. Other times they'll give us just the radius. So it does not matter. Just to keep our lives, a little easier, I'm going to have us memorize this one because then it's like just like 1 less letter. Circumference is pi times the diameter. We're going to keep it simple, but just know diameter is the same as 2 radiuses. 2 radii? I'll have to look into that. I think it's radii. That sounds maybe more grammatically correct. But circumference, one other thing, circumference is basically just the perimeter. We just finished perimeter and area of composite shapes in 2.1. Sorry, this is 2.1b, I just remembered. In 2.1a, last class, we were looking at perimeter and area of composite shapes. Actually, I think find a circle. What do I have? It's a circle. Dun, dun, dun. All right, I've got a lid. Here we go. I've got a lid for a bottle of water. So the circumference, right? If I'm asking you to find the circumference, or if I'm asking you to find the perimeter, right? Again, perimeter, we're imagining like we're walking around an object. From last class, our lesson, we talked about, right, like with wallpapers, like we've got a border of like a, what do we call it? It was like a crown molding trim, almost like baseboards for the room. We were helping, I think Alice was the name from that word problem, right? So circumference is just like perimeter. It's like we're walking along the outside. We just want that total distance, as if we're walking around this object. What's the total distance? So when we're talking about circumference, just think it's the perimeter for a circle. And then again, we'll add this to our notes next time we're in class. Okay, so we're gonna do this one together. We're gonna find the perimeter of this beautiful stained glass window. Wow, like 10 out of 10. I don't know about you guys, but this looks very complicated to make. I can only imagine like the price that this would be, how expensive this art piece would be, because that That looks horrible. I would not want to be the one that was commissioned to make this artwork. That'd be rough. That'd be rough. But anyhow, we're going to find the perimeter, right? Which again is the circumference. And before we dive in, we're just going to recap. Circumference, what do we know? We know that circumference, there's that ratio from Archimedes, that circumference divided by the diameter gives us pi, or kind of like rearranging that formula. Circumference is equal to the diameter times pi. Diameter times pi. So we're looking at this. What do you know? We're given the diameter. But another observation too, is there anything unique about this circle? Anything that we're noticing? I know it's mesmerizing with the Fibonacci sequence here of this spiral. But anything that we're noticing about this stained glass piece? This is a recording, so I don't know what you're saying, but I can only assume someone is recognizing, where's the rest of the circle, Mrs. A? You're like, oh my goodness, we are only given half of the circle. What? So we need to keep that into consideration. If we're using the circumference formula, that's to find the total of the circle. But in this stained glass piece, we're only given half. So we're going to we'll circle back to that. Haha, that was pretty funny. Dad joke. Okay, so we've got, right, we're going to be finding with this formula the entire circle, right? But we don't need the full thing. We just need half. We'll circle back to this again. Okay, so let's just find the circumference first, and then we'll work our way to that. Okay, so we are given the diameter, 3 feet. So let's plug it in. So 3 times pi, we can just leave it there. We can leave it in terms of pi, that's okay. So the full circumference is 3 pi, and I'm just going to show that as a visual here. This is what we just found. We just found this total circumference. Again, we are imagining that because we want the perimeter, maybe we are really interested in stained glass. Personally, I think it's really cool. That's something that I would like to learn how to do. But I gotta wait for my son to be a little bit older, because I feel like having sharp glass around, probably not ideal with a toddler. But one day, and I'll show you guys what it looks like. But we're gonna imagine that we are doing stained glass art. It's a new interest, right? We found it on TikTok. We're like, I can do that, right? And let's see. So we've just discovered the full total circle circumference, but again, we're only given half of the circle, so we just need half of this. So I'm going to just keep it in terms of pi. So really, 3 pi divided by 2, I'm going to color code. That's giving us this much of the circle. You guys with me so far? So I just divided it by 2. I know it looks really trippy. It looks kind of ugly like that. I can change it to be decimal, if that makes more sense. Maybe it'll make more sense. Let's change it to decimal, because maybe leaving it in terms of pi is too much for us. So 3 times pi, and then I'll put that in parentheses, divided by 2. Okay, so that is about right at the 10th place, 4.7. Okay, 4.7. That's the half, but we want the perimeter of the window. So again, we're imagining with perimeter, we're walking along the outside of a building, right? Or the stained glass. We'd have to be very careful not to break it. So what did we just find? We found this much of the circle, right? Because we found half of the circumference. Is that the total perimeter of this window? Is that everything? Are we done? Is there anything that we're missing? Again, imagining, visualize that we are walking along this. Hold on, I have a laser pointer somewhere here. Wait, please stay with me. Wait. Oh my goodness. I could have swore I had a laser pointer. It's fine, I've got a spotlight. Okay, this is so much better. Why have a laser pointer when you can have a spotlight? Okay, so stick with me here. So we're walking. Did we walk the full outside of the building? Did we walk the full distance? No, we're missing this segment down here. Oh, but lucky for us, they gave us that distance of 3 feet. So we're just going to add 3 to that, right? Because again, from the beginning, our goal was to find the perimeters if we're walking this entire object. This one was a little bit tricky because we're using circumference and adding onto it. That would give us, so perimeter equals 7.7 feet. Oh my gosh, it's in feet too. I can't even imagine that. I don't know how pricing goes for stained glass, but that seems huge. That looks like a huge piece. 3 feet? That's like off screen. That's pretty big stained glass window. Okay. All right. I'm glad we're not making this because that'd be really, really, really complicated. All right. Again, this is a recording, so when we come back to class, we'll add this to our Engagely notes. But on your Desmos, I hope you've got some of this work, and I hope this made sense. I'm going to have you on the next slide. Again, if I'm going too fast, pause, because it's a recording, you can pause. On slide 7, let me know. Go ahead and star. How are we feeling with this content? How are we doing with this topic? And I will be coming back to this and checking those of you that have been following along. If you made it this far in the video, awesome. Thank you for sticking with it. A+ for effort. I will be checking your Desmos when we get back for class, when we're meeting for class, and I will be giving extra credit points for those of you that have been following along, where you're showing this work on your Desmos. So again, easy slide for points. Give circle, check mark, right? We can't take the poll, but how are we feeling with circumference? Let me know. Take that poll. All right, next one, slide 8. Try this on your own. So a roundabout is a one-way circular intersection. Have you guys ever driven on a roundabout before? I feel like they're in a lot of like other countries, which is kind of cool, like to replace like a light, like a stoplight. But honestly, I feel like they're kind of, maybe because like we don't have like a lot of practice with them here, they feel like a little scary. I don't know. I'm just not like an aggressive driver, so I wouldn't like. I'm like, I'm so sorry. Like, let me just squeeze in here. Holding up the line behind me. Anyways, so this is a roundabout. In case you've never seen it before, it's pretty neat. Pretty neat. About how many feet would a car travel if it drove once around the roundabout? So in this case, right, we can start by annotating. What are we trying to find here? What's our goal? What are we doing? We want to find the distance around the roundabout, right? How many feet would the car travel if it drove once around the roundabout? Not 2 times, just once. So basically, what we're trying to find here is circumference. And this is much simpler than the last one because we don't have to add an extra distance, just the circumference. So pause this video, try this on your own, and then when you've got your answer, we'll check. All right. Assuming that you have paused the video, you've got your work, you're ready to check. Let's go. Let's get into it. So what do we know about circumference? Somewhere on your paper, I hope you wrote circumference is equal to diameter times pi. And look at us. Oh my goodness. They gave us the diameter. Right? It's like dead center in the circle. It's reaching end to end. So the diameter is 150. So bam, 150 pi. If you put that as your answer, you got it. Oh wait, no you didn't, because we need how many feet? In feet. Or again, if you don't like leaving it in terms of pi, let's check the actual exact distance. Because I didn't say rounding, like to the nearest tenth or anything. But that is equal to 471.2 feet. So this is our circumference. So either of those two answers, 150 pi or 471.2 feet, that makes more sense though to not leave it in terms of pi, right? Because especially for distance, like that might be a little more confusing. So we'll say 471.2 feet. That sounds like a really big rundown. Sounds a little scary. Okay. Again, this is a recording. We'll add this to our notes when we get back to class the next time. Brain break if you need it. Slide 10 with a partner, but this is a recording. So try this on your own. For this with a partner, try this on your own to the best of your ability. We've got dimensions of a tire to the nearest foot. How far does the tire travel when it makes 15 revolutions? So 15 revolutions, that's like 15 circles, right? So we'll find the circumference times 15 to get that distance. There you go. I'll help you guys out. When you click next, I have that formula, I believe. Let me double check. Yep. Distance traveled is the number of revolutions, so 15 times the circumference. Try that out. When you're ready to check your work, click next again, and you'll be able to check if you got it. All right, this one is optional. I'm not going to be grading this one, but I will be grading your work from these other slides. So from slide 8, 7, 6, and we'll say slide 4, making sure that you added pi. I'll be checking the slides next time we're in class, and if you got it, you get extra credit. All right, any questions, Canvas inbox, let me know. I'll see you guys later. Bye everyone, have a great day.